my name is Jeremy Heywood. I'm the diving safety officer at the Vancouver Aquarium. So we need to know, of course, a little bit about how to stay warm in the water out here so everyone is safe and happy. And of course, the same principles apply to surfing. So I thought I would do just a short talk on a couple of scientific things about staying warm. The first about why you get cold and what happens to your body. And also then a little bit about what neoprene is and how wetsuits are made. So it kind of ties in with everything. Now you know how to predict waves. You can get a nicely made board and you know how it's made. And now you can take it out and you can stay warm while you're using it. So the talk is called Stay Warm, Stay Happy. It's a good concept for anything other than surfing as well. So first of all, why do we get cold? Well, it seems obvious, but we'll state the obvious anyway. Heat flows, just like a liquid. It flows from places that are warm to places that are cold. Our bodies are warm, 37 degrees Celsius. The water out there, very cold. Right around now, it's probably not quite 7, maybe 9. Some people can correct me if I'm wrong, but it goes between about 7 and 15 degrees here in Tofino. So you can see the warmth is going to flow from our bodies into the cold ocean. The other thing, too, is water has an extremely high thermal conductivity. And that's a big sort of phrase, but all it means is that heat flows really quickly in water. In fact, it flows 25 times more quickly in water than it does in air. That's why you get much colder in water. So thermal conductivity is a very important sort of feature to understand about water. When you're jumping in the water, you get cold way faster, 25 times faster, in fact. What happens if you get cold? Well, you get hypothermia. What's hypothermia? It just means a lowering of the temperature. Hypo means less than, and thermia means temperature. So hypothermia. Hypothermia kicks in anywhere below 35 degrees Celsius. Now our body is, our core temperature, that's the inside, sort of the core temperature of our body, like I said, 37 degrees. Only a 2-degree drop, and we start to experience the effects of hypothermia. Of course, as you get colder, these symptoms get much worse. But even at only 35 degrees Celsius, mild hypothermia kicks in. And the sign for that is shivering. So folks, when you're shivering, you're hypothermic. So it's a really good warning sign for parents with kids out there, and even parents and surfers themselves, that when you are shivering, it's an early warning sign of hypothermia. You should get out of the water, get warmed up, and get dry. So shivering is a really good indicator. Also, other things that you probably know are your lips get blue instead of a nice regular color. Shivering gets worse, and then you stop being able to use your extremities, like your fingers and your toes stop working. And then as it gets worse, then you can't think clearly and you're unable to react properly to things that may happen, and then bad things happen from there. So that's why we get cold. So how do we keep warm? Well, there are two main ways to keep warm. First one applies to surfing and any water sport, as well as lots of other things as well, just walking around today out in the environment. And that is by insulating. So insulating reduces the heat transfer between objects. So by putting some stuff between something that's cold and something that's warm, we actually reduce that heat transfer, and we can keep that body inside on the one side of that stuff warmer than the environment on the outside. And materials with lots of air spaces are really good insulators. As you probably already know, intuitively know, that things with air spaces that are really puffy are nice insulators. Those things include a bunch of natural things like down, or the feathers, the little fluffy feathers that anyone slept here last night, you were covered with in your comforter, probably. So there's a feather. Fur, of course, and hair to a lesser extent, but fur. Sea otters have amazing insulating fur. If you have a chance, you should go and visit the Aquavan. Do you guys still have a sea otter pelt that you hand around? Yeah, so if you've never felt a sea otter pelt, the fur of a sea otter, if you have a chance to visit the Aquavan in Ucluelet, it's amazingly dense and thick and super insulator. Also wool, of course, sheep make wool for us that we make sweaters and all kinds of insulative materials out of. Artificial insulators or synthetic insulators, things like fiberglass. Again, it's just sort of a synthetic version of wool. And there are all kinds of synthetic microfibers in these high-tech sleeping bags and parkas and mountain climbing equipment. And also neoprene. Neoprene is a great insulator. It's a synthetic rubber that's manufactured and can actually foam it up with some sort of bubbles, either nitrogen or air. and it foams up, and it's these bubbles in the neoprene that provide the insulation. So that's one way of staying warm. The other way of staying warm is of course, to stay dry, because as we learned, if you're wet, heat goes away 25 times faster. So staying warm, insulated, and dry, or sorry, staying insulated and dry are good ways to stay warm. That's exactly what a wetsuit does for you. It keeps you dry mostly. A good one does anyway. And it keeps you warm because it's got some insulation in it. So in case you don't know what a wetsuit is, well, it's a really snug fitting, yes, my assistant is pointing to the wetsuits on the side table there. It's a very snug fitting piece of gear that's made out of neoprene and some other stuff, but mainly neoprene, all right? And that, like I said, neoprene is a synthetic rubber that's foamed up with some bubbles in it. Those bubbles are what provide the insulation. Here's a close-up shot of a piece of neoprene. If you can't see it in this slide, I've got this actual piece right here. You can see the tiny little bubbles in here. This is a piece of 10 millimeter neoprene that you would never wear for surfing, but it's good to show you the bubbles. It's these actual bubbles that provide the insulation. Of course, the thicker it is, like this 10 mil piece here, the thicker it is, the warmer it is, but the less flexible. When you're surfing, you want to have a nice flexible suit, so surfing wetsuit neoprene is much thinner, and the high-tech neoprenes are very stretchy and soft and very comfortable and flexible, but still provide some warmth because of that insulative neoprene. So here, average suit thickness 5 to 6 mil for the winter, 4 mil or less for the summer, depending on the temperature. And that thickness gives you a nice balance of warmth and flexibility that you need when you're jumping up and down on your board. So you can also, of course, add accessories to stay warm, gloves and a hood, also made of neoprene, mainly as the insulating material, but also other materials to make them comfortable. Like sometimes they have a nice soft lining inside and whatnot. So in case you, just because I wanted to make this sciencey, I put the chemical formula for the single molecule that makes neoprene. Neoprene is basically a type of, it's a synthetic rubber. It's kind of a plastic. It's a poly molecule. So if you take this molecule and you link a bunch of them together, you get a big molecule that makes neoprene. Neoprene is made in a factory in big sheets, and when wetsuit manufacturers get it, they get these big sheets, and they cut them down with a pattern into the shape that they need, and they sew them together, which leads me to my next slide. However, just keep in mind that because we want to stay dry as well as insulated, the most important feature when choosing a wetsuit is fit. The wetsuit has to fit properly, nice and snugly, because if it doesn't fit, where's water going to go? Is it going to stay out, or is it going to go in? No, if it doesn't fit, if it gapes at the neck, or if the sleeves don't fit properly, or the big baggy parts, water will get in there and it'll flush through, and it'll flush all that nice heat away, and you'll get wet, and you won't be insulated because the water's taking all that heat away. So when you're choosing a wetsuit, it doesn't really matter what it is as long as it fits properly. So number one consideration for choosing a wetsuit. After that, probably the second most important consideration is the color. So just very briefly, a little slide on how these wetsuits are made. Pretty cool. I visited a factory in Vancouver that actually makes dry suits more than wetsuits, but the techniques are exactly the same. Get a whole bunch of sheets of neoprene all stacked together. That's what this first slide is here on your left there. Stack a bunch of sheets of neoprene together with the pattern drawn out on them. Then they have this big, cool sliding knife that they drive around and cut out the pattern pieces. The pattern pieces are then all laid out and assembled and then glued together with a special glue that bonds the seams together. And then those seams, after they're glued and stuck together, then they're stitched. And the stitch that is used is a special stitch called a blind stitch. And what that means is that the thread doesn't actually penetrate all the way through the neoprene. If the thread penetrates all the way through, what do you think else is going to come through that hole? Well, water, of course, and we don't want water to come in. So a good wetsuit, anyway, will have glued and blind stitched seams. And there's a fancy sewing machine used for doing blind stitching. I watched it work. It's very strange, but kind of cool, too. And then you can additionally reinforce those seams by putting some sort of flexible seam weld on them. And there are a couple suits over here that have the seams welded. Now, when you do this with a suit, it makes it a little bit more expensive. So quite often with suits, you do get what you pay for. If you're paying a bit more, you're going to get good seams. You're going to get them stitched properly. You're going to get them seam welded. You're also going to get other fancy but generally useful features like suit entries that actually seal up and prevent water from coming in, and good zippers and good cuffs and ankle cuffs and wrist cuffs that keep the water out. So, so you do usually get what you pay for when you buy a suit. If you buy a very cheap, inexpensive suit at Costco, you're probably just getting a suit that's got this what's called flat lock stitching. And that's just a stitch that sews two pieces together, but the needle actually goes through the suit. And if you stretch it and hold it up to the light, you'll actually see light coming in through those stitch holes, which obviously is not good for keeping folks warm. So bear in mind that there are lots of different ways of making a suit, and you want to learn about that before you go out and drop a bunch of money on them. So that's basics for making a suit. Because we've got a pretty short talk, I just wanted to finish off with a couple of key points. It doesn't matter if you remember anything I just said about blind stitching or heat capacity of water or thermal conductivity. Remember these things. You get cold way faster when you're in the water. If you're shivering, get out, dry off, and warm up, especially for kids. Kids lose heat really fast and are get hypothermic more quickly because they've got less, let's call it inherent insulation on them, usually. When you're choosing your suit, make sure it fits properly, and make sure you're choosing the right gear for the conditions. So do all your research, know what it's like out there before you pick your 2 mil shorty, okay? If it's like that, you're probably not going to wear that today, otherwise you might be getting rescued. So, and of course, because it's my job to say this, stay safe. Right? I'd just like to thank O'Neill helped me out a lot with some info about wetsuits, and also Brooks is a great company that makes dry suits for us in Vancouver. They helped me out as well, so thanks to O'Neill and Brooks. So.
Thank you very much, Jerry.